Hey, ever wondered how chemists figure out exactly when two chemicals have reacted in perfect proportion without relying on color changes or fancy indicators? Let me walk you through potentiometric titration, a super clever method that lets you see reactions with electricity instead of your eyes. Alright, so here's the big idea. Every solution has its own electrical potential, or voltage, depending on what ions are floating around. And as you add a chemical, let's call it the titrant, to another solution, the mix starts to change. The ions shuffle and the voltage shifts. Chemists use the Nernst equation to connect these dots, but honestly, all you need to know is as the reaction happens, the voltage changes in a way that's super useful. Here's how the setup works. Imagine two electrodes dipped in your solution. One's the reference electrode, usually something like a silver-silver chloride stick, and the other's the indicator electrode, which could be a glass pH probe or a sleek metal one. These are hooked up to a voltmeter or even a pH meter. Now, you start adding your titrant bit by bit, and after every addition, you jot down the voltage. Once you plot voltage versus the amount of titrant you've added, a curve starts to form. The magic happens at the equivalence point. That's where the reaction is perfectly balanced, and you'll see a sudden, dramatic jump in your curve. Think of it like this. At the start, the voltage changes slowly as you add titrant, but as you get closer to the equivalence point, it takes off like a roller coaster cresting a hill. After the equivalence point, everything calms down again. That sharp jump? That's your chemical handshake, telling you the reaction is complete. Now, why go through all this instead of just using a color change? Well, potentiometric titration is a lifesaver for solutions that are colored, cloudy, or just plain hard to see through. No indicator? No problem. Plus, it works for a whole range of reactions: acid-base, redox, complexometric titrations, and even precipitation titrations. It's also perfect for super dilute solutions, or when you've only got a tiny sample to work with. Let's run through a quick example. Say you're titrating hydrochloric acid with sodium hydroxide. At the start, the voltage creeps up bit by bit, but as you get close to neutral, the magic pH 7, the voltage jumps sharply. That's your equivalence point. Add more sodium hydroxide, and that sharp rise flattens out again. So, potentiometric titration lets you pinpoint exactly when your reaction is done, no matter what your solution looks like. And if you're someone who likes to see things visually, I can sketch out that classic titration curve for you. It'll make the whole idea click instantly. Interested? Let me know in the comments. Thanks for sticking around. If this made chemistry a bit more electrifying for you, don't forget to like and subscribe for more simple science breakdowns. See you next time!